Have you ever wondered what secrets Jupiter, the largest planet in our solar system, might be hiding? It's an intriguing thought, isn't it? Jupiter, the fifth planet from the Sun, is a behemoth among its planetary siblings, with a mass that is 2.5 times that of all the other planets in the solar system combined. It's a gas giant, composed primarily of hydrogen and helium, much like the Sun. Jupiter is not just large, but also ancient. Scientists believe it was one of the first planets to form around 4.5 billion years ago. It is so massive that its gravity has a significant impact on the orbits of other celestial bodies in its vicinity. Its strong magnetic field, larger than the Sun's, produces stunning auroras at its poles, similar to Earth's northern and southern lights. Its size and ancient origin suggest that Jupiter might hold keys to understanding the early solar system's formation and evolution. Yet, despite its importance and the numerous missions that have studied it, much about Jupiter remains a mystery. Its thick cloud cover hides its interior from view, obscuring our understanding of its composition and structure. Jupiter's most recognizable feature is the Great Red Spot, a storm larger than Earth that has been raging for at least 300 years. But the planet's weather is not its only fascinating feature. Jupiter also has a strong magnetic field that creates stunning auroras at its poles. And then there's the matter of Jupiter's moons. If you think our Earth's single moon is impressive, consider this. Jupiter has a staggering number of moons. These moons range in size from tiny moonlets less than a mile in diameter to vast worlds larger than some planets. Each of these moons has its unique characteristics and mysteries to unravel. But what if I told you Jupiter had not one, not two, but 92 moons orbiting around it? Jupiter's moons weren't discovered overnight. It was a journey of centuries. A journey that began on a cold January night in the year 1610, when the Italian astronomer Galileo Galilei pointed his newly constructed telescope towards Jupiter. What he saw changed our understanding of the universe forever. Galileo noticed 4 small points of light near Jupiter that he initially took for stars. However, over several nights, he observed that these stars were moving in a way that was inconsistent with the other stars in the sky. Instead, they appeared to be orbiting Jupiter. He had discovered the first 4 moons of Jupiter, now known as the Galilean Moons, Io, Europa, Ganymede, and Callisto. This was a groundbreaking discovery, as it was the first time anyone had observed objects orbiting a planet other than Earth. The next significant discovery didn't come until over 2 centuries later. In 1892, Edward Emerson Barnard, an American astronomer, discovered the 5th moon of Jupiter, which was later named Amalthea. Unlike the Galilean moons, which are some of the largest objects in our solar system, Amalthea is much smaller and was only able to be found thanks to advancements in telescope technology. As the 20th century rolled around, our technological capabilities advanced at an unprecedented rate, and so did our knowledge of Jupiter's moons. In the early 1900s, 4 more moons were discovered, followed by 12 more in the 1950s and 60s. By the end of the 20th century, we knew of 26 moons orbiting Jupiter, but the advent of the 21st century brought with it a wave of new discoveries. The Galileo spacecraft, named after the man who started it all, arrived at Jupiter in the late 90s and began sending back a wealth of data. This data led to the discovery of dozens of new moons, pushing Jupiter's moon count into the 40s and 50s. But the discoveries didn't stop there. In the early 2000s, the advent of digital imaging and more powerful telescopes led to the discovery of even more moons. Astronomers scoured through vast amounts of data, finding tiny points of light moving against the background stars. Each one of these points of light was a potential new moon. By 2018, the count was up to 79. The most recent discoveries were made in 2018 when a team of astronomers led by Scott S. Shepard discovered 12 new moons, bringing the total known moons of Jupiter to a staggering 91. Then, in 2020, another moon was discovered, pushing the count to an even more astounding 92. Each of these moons is a unique world with its own characteristics and mysteries. Some are tiny, no more than a kilometer across, while others, like Ganymede, are larger than the planet Mercury. Some are icy, while others are rocky. Some orbit close to Jupiter, while others are so far away that they take years to complete a single orbit. The discovery of these moons has not only expanded our understanding of Jupiter, but also of our entire solar system. They provide us with a window into the past, offering clues about the formation and evolution of our solar system. They also raise new questions and mysteries, fueling our curiosity and driving our desire to explore. So whether it's the icy surface of Europa, the volcanic activity on Io, the craters on Ganymede, or one of the many other moons, each new discovery brings us one step closer to understanding our place in the cosmos. And so, over centuries of exploration and technological advancement, we have come to know of 92 moons of Jupiter. And who knows, with our unending curiosity and ever-advancing technology, perhaps there are still more moons waiting to be discovered. The first 4 moons of Jupiter, discovered by Galileo Galilei, hold a special place in this grand tally. Enter the Galilean Moons: Io, Europa, Ganymede, and Callisto. These celestial bodies, first spied on by Galileo's telescope in the early 17th century, are not just mere specks of light in the night sky. They are worlds in their own right, each with distinct characteristics that make them uniquely captivating. First on our list is Io, the most volcanically active body in our solar system. Imagine a world where the ground beneath your feet is constantly reshaping itself. Mountains form in the blink of an eye, only to be swallowed by eruptions just as quickly. This moon is a fiery spectacle with over 400 active volcanoes spewing sulfur across its surface. Io's vibrant yellows, reds, and blacks paint a vivid canvas of ceaseless change and activity. Next, we journey to Europa, a moon that couldn't be more different from its neighbor. This icy world gleams in the sunlight, its surface a cracked shell of ice over a speculated ocean. The possibility of a liquid water ocean beneath the icy crust of Europa has tantalized scientists for years. Could there be life beneath those icy depths? This question fuels the excitement and curiosity for future missions to this icy moon. Our third stop is Ganymede, the largest moon in our solar system. Bigger than the planet Mercury, Ganymede is the only moon known to have its own magnetic field. Its surface is a mix of 2 terrains: older, heavily cratered regions and younger regions marked by grooves and ridges, suggesting geological activity in its past. Ganymede is also believed to house an underground ocean, much like Europa, adding to the intrigue of this massive moon. Finally, we reach Callisto, the outermost of the Galilean moons. Callisto is a heavily cratered and ancient surface, a record of the solar system's history. Unlike its siblings, Callisto shows no signs of internal activity and is thought to be geologically dead. But don't let that fool you. Its ancient and heavily scarred surface tells a story of countless celestial impacts over billions of years. The discovery of these moons marked a turning point in our understanding of the universe. When Galileo first observed these moons in 1610, it challenged the prevailing belief that Earth was the center of the universe. Here were celestial bodies that clearly didn't orbit Earth, but Jupiter. This discovery was a key piece of evidence that supported the heliocentric model of the solar system, where the Sun, not Earth, is at the center. Beyond their historical significance, the Galilean moons have also been valuable targets for scientific exploration. Spacecrafts have flown by, orbited, and even landed on these moons, sending back invaluable data. They have helped us understand not just more about Jupiter, but about the formation and evolution of our solar system as a whole. It's worth noting that each of these moons could easily merit a deep dive of its own. From Io's volcanic fireworks to Europa's potential for life, Ganymede's magnetic personality to Callisto's ancient exterior, each moon is a world waiting to be explored further. Even though these moons were discovered over 4 centuries ago, they are far from being fully understood. They continue to surprise and fascinate us. Each new discovery, each new image adds another layer to our understanding, yet also seems to add more questions. It's a reminder that space exploration is not just about finding answers. It's about the journey, the sense of wonder, and the joy of discovery. Despite their differences, these 4 moons have one thing in common. They orbit the giant planet Jupiter, a part of its gravitational dance. In a way, they're a family, bound together by the laws of physics. They showcase the diversity of celestial bodies in our solar system, from fiery volcanic landscapes to icy, potentially habitable worlds. Even today, these 4 moons continue to fascinate scientists and space enthusiasts alike. They're a testament to the enduring power of curiosity and exploration, a reminder of just how much there is to discover in our incredible universe. Beyond the Galilean moons, there's a whole other world of moons orbiting Jupiter. As we venture further away from the giant planet, we encounter an array of smaller moons, each with its unique characteristics and orbit. These moons, while less famous than their Galilean counterparts, are just as fascinating and significant in understanding Jupiter and its complex system. First, let's talk about their sizes. These moons are considerably smaller than the Galilean moons, ranging from about 1 mile to over 100 miles in diameter. They're so small that many of them weren't discovered until the late 20th and early 21st centuries. Despite their size, these moons play a crucial role in the Jovian system and have unique features that set them apart. Take Metis, for instance, Jupiter's closest moon. It's barely 37 miles across, yet it orbits so close to Jupiter that it's within the planet's Roche limit. This means that the tidal forces exerted by Jupiter are so strong that they could potentially tear Metis apart. Despite this, Metis continues its rapid orbit, completing a full revolution around Jupiter in less than 7 hours. Then there's Themisto, a small moon with a highly eccentric orbit. Discovered in the year 2000, it's only 5 miles in diameter and has an orbit so eccentric that it takes nearly 130 days to orbit Jupiter. Its discovery was a surprise to astronomers who hadn't expected to find a moon with such an unusual orbit. And let's not forget about Himalaya, the largest of Jupiter's irregular moons. With a diameter of about 170 miles, it's about the size of a small city. It's also one of the few moons that orbit Jupiter in a prograde direction, meaning it orbits in the same direction as Jupiter's rotation. Moving on, we have the CARM group, a family of 16 moons that share similar orbits and characteristics. Named after their largest member, CARM, these moons are believed to have originated from a single larger object that was shattered by an impact. Next up is S2003J2, the most distant moon of Jupiter. It takes about 2 years to complete one orbit around the planet. This moon is so distant and small that it wasn't discovered until 2003, hence its name. Now you might be wondering, how were these moons discovered? Well, the credit goes to several dedicated astronomers and the advancement in technology. While Galileo Galilei discovered the 4 largest moons with a simple telescope, the discovery of these smaller moons required more sophisticated equipment. Many of these moons were discovered during the Voyager missions in the late 1970s, while others were found by ground-based telescopes in the late 20th and early 21st centuries. Some were even discovered by amateur astronomers who dedicated their time and resources to exploring the night sky. The discovery of these moons has added to our understanding of the Jovian system and has opened up new avenues for exploration. Each moon, with its unique orbit and characteristics, provides valuable insights into the formation and evolution of Jupiter's system. They also raise fascinating questions about the processes that led to their formation and the possibility of life beyond Earth. For instance, the discovery of water ice on the surface of some of these moons has led scientists to speculate about the possibility of subsurface oceans. While this is purely speculative at this point, it's a tantalizing prospect that could have profound implications for our understanding of life in the universe. In conclusion, the other moons of Jupiter, while less known, are just as fascinating and significant as the Galilean moons. They provide a glimpse into the complex and dynamic system of Jupiter and offer exciting possibilities for future exploration and discovery. Each of these moons, in their own unique way, contribute to the complex and intriguing system of Jupiter. They remind us that there is still so much to discover in our solar system and beyond. Every new discovery, no matter how small, adds to our knowledge and understanding of the universe in which we live. So, the next time you look up at the night sky, remember that there's a whole other world of moons out there just waiting to be explored. Why does it matter that Jupiter has so many moons? Well, Jupiter's moons are much more than just celestial bodies orbiting the largest planet in our solar system. They are vital keys to understanding our universe and our place in it, offering us clues about the formation of the solar system, the possibility of life beyond Earth, and extending our knowledge of planetary science. Let's start with the formation of the solar system. The moons of Jupiter are like a frozen snapshot of the early solar system, preserved in time and space. Each moon, with its unique characteristics and composition, represents a different stage in the evolution of our solar system. For example, the 4 largest moons, known as the Galilean moons, are believed to have formed from a circumplanetary disk around Jupiter, similar to the protoplanetary disk from which our own solar system evolved. By studying these moons, scientists can piece together the story of how our solar system came into existence billions of years ago. Next, consider the tantalizing prospect of life beyond Earth. Two of Jupiter's moons, Europa and Ganymede, are believed to harbor subsurface oceans of liquid water, heated by the gravitational tug of Jupiter. These oceans could potentially harbor microbial life. If life were to be discovered on these moons, it would completely redefine our understanding of where and how life can exist. It would mean that life is not unique to Earth, but could thrive under extreme conditions in other worlds. Jupiter's moons have also influenced our understanding of planetary science. For instance, Io, the most volcanically active body in the solar system, provides a unique opportunity to study volcanic processes and geology on other planets. Ganymede, the largest moon in the solar system, possesses its own magnetic field, offering insights into the magnetic fields of other planets. Callisto, with its heavily cratered surface, serves as a record of the impact history in the solar system. Furthermore, the moons of Jupiter have cultural significance too. Since ancient times, humans have looked up at the night sky and been inspired by the celestial bodies they see. The moons of Jupiter, visible from Earth with a simple telescope, have sparked curiosity and inspired countless stories, myths, and works of art. They have also been the setting for numerous science fiction novels and films, capturing the imagination of millions. Importantly, Jupiter's moons also serve as a stepping stone for human exploration of the outer solar system. NASA and other space agencies have plans to send missions to these moons in the future. These missions will not only increase our understanding of these moons, but also test technologies that could be used in future human missions to the outer planets. The significance of Jupiter's moons extends far beyond their mere existence. They are scientific treasures that hold the potential to answer some of the most fundamental questions about our universe. How did the solar system form? Is there life beyond Earth? How do planetary processes work? They inspire us, they intrigue us, and they offer us a glimpse into the vast and complex universe that we are a part of. So the next time you look up at the night sky, remember that each point of light you see, each star, each planet, and each moon holds a universe of possibilities for discovery. And among them, the moons of Jupiter, in their multitude and diversity, offer a universe of possibilities for discovery. The story of Jupiter's moons is a testament to our relentless pursuit of knowledge. We've journeyed through the cosmos, diving deep into the mysteries of the largest planet in our solar system. In this quest for understanding, we've uncovered the significance of these moons, not only in the context of Jupiter, but also in the grand scheme of the universe. Each discovery, each revelation, brings us one step closer to comprehending our place in the cosmos. Yet, as much as we've learned, there remains an infinite expanse still waiting to be explored. Our journey is far from over. As we continue to explore the cosmos, who knows what other secrets Jupiter, its moons, or the other celestial bodies hold for us?